After you've installed SF-Nav onto your PC, the first thing we'll do is set up the configuration of your system. To do so, go to the Start menu, select All Programs, JASCO, SF-Nav, and SF-Nav Configuration, and the window you see here will pop up. The first thing we'll do is select File and New, as we are creating a new configuration. You'll see List is highlighted, which lists the components that are configured. Of course, this list will change as we configure our system. The first option is the CO2 and Solvent section. We have one CO2 cylinder, which of course is manually open and closed, and we do not have a CO2 mass flow meter, so we'll leave that unchecked. We have one solvent connected to the pump, so we can tell it we have one. We do not have a CO2 recycler in this system, so we leave that unchecked. In the pump section, we do indeed have one CO2 pump, which is the PU2088-CO2. It has a maximum flow of 150 mils a minute and a max pressure of 40 megapascals. It is communicating to the software through RS-232. We have two solvent pumps. Pump number 1, the PU2088, is our modifier pump with a maximum flow rate of 100 mils per minute, a maximum pressure of 40 megapascals, and it does not have a solvent selection or low pressure gradient unit connected, so we tell it none. And it also uses RS-232 for communication. Pump number 2 is the PU2086 makeup pump. That has a maximum flow of 20 mils per minute and a max pressure of 40 megapascals. Also, no solvent selection or low pressure gradient unit, and thus we select none, and it uses RS-232. Next, in the valve section, we have selector valves and 8-way valves being used in the system. We have 3 selector valves and 1 8-way. So we'll need to name those. The first selector is the waste collect valve for the fraction collector. It'll start in position A and is using the Floam DIO communication. Click Apply and you'll see it changes the name. The selector valve number 2 is for a large volume injector, and this is the selection valve. It'll start in position A and also uses the Floam DIO. Click Apply and it changes our name. The third is also for the LVI and is the injection valve. Starting in position A and again using the Floam DIO, we click Apply. The last valve, the only 8-way valve we have in the system, is our fraction valve. It'll start on fraction 1 and use Floam DIO, and you'll see the name changes. Now, as we tell the system we have a waste collect fraction valve and a fraction valve selecting which fraction we're going into, that of course means we have a recovery section, a fraction collection section. We just simply need to tell it which valve is being used for the waste collect and which valve is being used for the fraction determination. We do indeed have a chiller on this system, however, it is not being controlled by the software, and thus we leave the box unchecked. We also have a mixer in the system, however, it is also not being controlled, and thus we leave that unchecked. We do indeed have multiple heaters throughout the system, 3 of them, the first of which is located just after the CO2 pump, so we'll call that the CO2 heater. It has a maximum temperature of 80 degrees, and the initial conditions will set to be 30. It uses RS-2485 for communication. The second heater in the system is within the fraction hood, just after the back pressure regulator, so we'll call this the collection heater. It also has a maximum temperature of 80 C. We'll start at 30 and is also communicating through RS-485. The third heater, which are the fraction heaters, has a maximum temperature of 80 degrees, initial of 30, and uses RS-485 as well. The column oven we're using is the CO2060, has a maximum temperature of 80, initial of 30, and uses RS-232. We do not have an additional oven, so we leave that unchecked. We have a back pressure regulator in the system, the BP2080, which has a maximum pressure of 50 megapascals, maximum temperature of 80, and will start at 30 degrees, and it communicates through RS-232. The detector we're using on this particular system is the UV2075, which has a wavelength range of 190 to 900. And because we have the high pressure preparative flow cell, it's a 1 millimeter path length and uses the RS-232 for communication. If you have additional detectors, such as the CD detector, you check this box. Or if you have additional auxiliary detectors, you check this box and can name them. However, in our case, we'll simply just tell it, as seen, that analog channel 1 is our UV detector. We do have a large volume injector in this system, so we'll check that box. The pump being used is another PU2086. Max flow of that pump is 20 mils per minute, and the max pressure 40 megapascals. It is also communicating through RS-232, and if you recall to the valve section before, we have two additional valves, the LVI selection valve and of course the LVI injection valve. We do not have a manual injector on the system, so we leave that box unchecked. We also do not have an auto sampler. We also do not have a temperature indicator, and we do not have any external event outputs. There's no pressure gauge or flow meter. Now we simply need to tell the PC which particular ports are being connected. For the RS-232 modules, we'll click Assign Port, and we of course notice the components we've configured. Typically, your port numbers will go in order. However, of course, you'll need to make sure these are the correct connections that are going to the communication box. Once you've done that, click Apply. For our RS-485s, we of course have our heaters. Again, we'll set the order of these and click Apply. Now the last ports to assign are for the valves. We click Assign Port Numbers, and we see how we have our valves here. The inputs are all default, and we just need to tell it the start port numbers, which in this case is 5, 33, 36, and 17. And if we scroll over, our outputs are default and they are correct. And our second port number list are as shown. We click Apply, and we're finished assigning the ports. We next go to the other section, where we need to tell it the Ethernet IP address in order to communicate. The typical address to be used is 192.168.14.11. And now we'll want to, of course, confirm that matches the PC by going to the Start menu, Control Panels, Network Sharing Center, Change Adapter Settings, and in this particular local area connection is the one that is connected to our system. So if we right-click, select Properties, and go to our Internet Protocol version 4, we click Properties, and we'll see 192.168.14.1, which is correct. we'll have 1 as the last digit, whereas you see above, we have 11. That's how it should be set up. Click OK, close, and you can close. At this point, we can go back to the list and see we have a lot of different modules, and obviously this has changed, as well as you see a slightly different IP address than before. We'll want to save this communication configuration as our default and click Save. Now the last thing we'll need to do is register that system configuration by clicking System Registration, selecting our default configuration that we just made, and clicking OK. Now once we've done that,